Hello friends, welcome to the next set of 5 questions. Question number 191. A coil has a resistance of 4 ohm and an inductance of 31.8 millihenries connected across 250 volt 50 hertz AC supply and it takes a current of 10 ampere. What will be its power in kilovolt ampere? That is, kilovolt ampere means we just need to multiply the voltage and the current. No need to worry about this power factor or cos phi. Okay, we just need this voltage and current. So what is that? Voltage is 250 and current is 10 ampere. So it is 2500 VA, or it is, if we need in kVA, it is 2.5 kVA. So option D is the right answer. Next question. Instantaneous value of voltage across a capacitor is 10 farad. Capacitor of 10 farad is Vm sin 314t. What will be the reactance of the circuit? Reactance means, since it is a capacitor in the circuit, we have a capacitive reactance. Capacitive reactance, and the formula is Xc is the representation. Formula is 1 by 2 pi Fc, and it is 1 by 2 pi Fc. What is 2 pi F value? We have this instantaneous representation, that is Vm sin 2 pi Ft is given. So 2 pi F is the coefficient of T, that is 340. So 2 pi F I can replace it with 314. And what is C? Capacitor is 10 watt, 10 farad. So it is 1 by 3140, or since it the options are in pi, have a pi in it, it is 3.14 into 100, I mean 1000, isn't it? 3.14 into 1000 is 3140. So it is 1 by pi into 1000. 1 by 1000 pi. Option C is the right answer. Next question. Question number 193. A 1.5 kilo ohm resistor and a coil, an inductor, 2.2 kilo ohm inductive reactance are in series across 18 volt AC source. The power factor is. So before trying to do this, let's check on the options. It is 564.564, 5.64, 56.4. See, power factor means cos phi, and cosine value ranges between cosine value ranges between -1 and 1, or cos theta. Generally cos theta lies between -1 and 1, but our power factor lies between 0 and 1. Okay, we have to get the power factor value. So it will be in between 0 and 1. That is, option B is the right answer. And question number 194. See, another way for this 193, or the proper way to do this question number 193 is cos phi. We have the resistor value and the inductive reactance value. So the impedance triangle is like this. If this is the resistance value, this will become the inductive reactance value, and this is the Z representation. Angle between R and Z is phi. So cos phi is adjacent side divided by hypotenuse, and hypotenuse you get by the Pythagoras rule, that is Z is equal to root of R square plus XL square. For this question, R is directly given as 1.5 K, and XL value is also given like, what is that, 2.2 K square. Okay, so this is the proper way of getting this power factor value. But since we have the options like this, of this sort, we can calculate the range. We can see the range of PF and finally arrive at the solution. Moving on to the next question. Question number 194. If 47 ohm resistor is in series with an inductive reactance of 120 ohm, across an AC source. The impedance expressed in polar form. Impedance means, again I just wrote the equation, it is root of r square plus x square. If it is x here is the inductive reactance, if it is capacitor, it is x is going to be the capacitive reactance. Anyway, this is root of 47 square plus 120 square, isn't it? 47 square plus 120 square. Now before doing this bigger calculation, just see to this options. Option A is 47. Here this polar form means it is set angle theta, where theta is the angular separation of r and z from the impedance triangle. It is got theta is the angle between r and z. So z is the impedance value, which is root of r square plus x square. Anyway, this z value is not going to be 47 because z value is greater than 47, also z is greater than 120. So we can easily eliminate this option A and B. Now next option C is having the z value same. So we can confirm that this value is going to be 129 alone. Okay, now our next duty is to check out the theta value, if it is 31.4 or 68.6. Okay, so when I draw this impedance triangle, in this right angle triangle or this impedance triangle, this theta is going to be 45 degree if r and x is equal. Okay, that is the rule of triangles. If both these perpendicular sides r and x are going to be equal, then we will have a 45 degree. But here for this question, r value is 47 and x value is 120, which is double this, isn't it? So this 45 degree is going to be little more bigger because it is getting this x value is double this r. So we have a value more than 45. So from the options C and D, 68.6 degrees more than 45 degree. Okay, so option D is our right answer. Okay, even for this question also you can have the proper method of solving. Since you have r and x value, uh, you can easily get the correct answer, the correct angle between r and z. Moving on to the final question for this session. Question number 195. What will be the value of average power in watt of a sinusoidal voltage applied across a series circuit of 20 sine omega t volt, 20 sine omega t volt, and the current flowing through the circuit is 10 sine omega t plus 60. Okay, so this is the V value and this is the I value. We have to get the average power, or it is in watts. Watts means it is VI cos phi. Okay, so since it is an AC system, it is VRMS IRMS cos phi. Okay, now from this equation it is clear that this is V max, isn't it? Vm sin omega t, this is Vm sin omega t. How to get Vrms from this? Vrms is Vm by root 2 and similarly IRMS is Im by root 2, and cos of angle between V and I is your phi. So since both are in sine representation, here sin omega t plus 0, and here it is sin omega t plus 60. So the angular separation is just 60 degree, isn't it? So it is cos 60. Now what is Vm and Im? Vm Im is directly taken from here. 20 is your Vm and Im is 10. Root 2 into root 2 is 2. Cos 60 is half. So this is coming about 200 by 2. 100 by 2 is 50. Okay. So 50 watts is your answer. So we'll be coming back soon with the next set of questions. Thank you.